Hi guys, welcome to Easy Service. I hope you are all doing well. Okay, so in this video, we want to quickly show you on how to compute for the correction, right? The correction for each successive station so that will aid us to get the corrected coordinates, which is the final and primary aim of forward computation um, sheet. So we want to quickly show you on how to do that. So from our previous video, we showed us on how to compute for the uncorrected coordinates, which are these values above each stations. Okay, and in this video, we just quickly illustrated we just quickly show you how to get the correction. So from this last end, we want to start from here because this is the station 2, which is the non-control. So all we have to do is to get the difference between this corrected and the uncorrected for the distance, and we are going to get the difference between the corrected and the uncorrected for the nothing. So when we do that, we are going to have this value by punching it. So just doing that, these are the values for the distance we have 0.006 and for the nothings we have 0.049. So therefore we are going to be introducing the sign. We want to know if we are to spread across with a positive sign or spread across with a negative sign. So how to know the exact sign is just this way. It's that simple and easy. Just carefully understand the concept and the logic behind it. So if you check the corrected coordinates, this is the value for the distance. It's a value that is greater than, all right, the uncorrected, right? So when you have the corrected value greater than the uncorrected, you should know that this error here will, because at the end of the day we want to achieve the corrected, so we need the particular value that we are going to add or subtract to have this uncorrected, and we just get that value by doing the difference between the corrected and the uncorrected, and this is the value. So we want to know if we are to add this value to this uncorrected to get this corrected, all right? So we want to know if we are to add it or we are to subtract from it. So the logic is just that this value is greater than this value, so therefore we are going to add this correction to this uncorrected to have the corrected. Do we understand it now? So in case you still feel a little bit confused, just rewind the video and listen all over again to get it. So we are going to be introducing the positive sign behind this value. Alright, that we want to add this value to this uncorrected, okay, to now achieve the corrected for photo 001. Right, so for this particular column, which is the nothings, if you check, we have this value and it is greater than the uncorrected. In some cases, you may have a value that is less than the you may have a value that the uncorrected value is greater than the corrected. So in that case, you'll be minusing, you'll be subtracting. Do we get it now? But in this case, right, we have a value that is less than the corrected, right? The uncorrected is less than the corrected. In some case, you may have a positive sign here and have a negative sign here, while in some case you have positive and have negative. And in some case you may have negative, negative, while in this case we are having positive, positive, because this particular value, which is the corrected, is greater than this uncorrected. So this value now will be added to this to get this. Do we get it now? So in this case, it is positive. Do we get it? So that's just the logic and the idea behind this. So we are going to be spreading this error across these unknowns so that we are going to obtain their own corrected coordinates as well. So just carefully follow me. So this is the formula we are going to be applying, all right? We are going to be applying this particular formula here, which is error over total arithmetic sum, okay, multiplied by the arithmetic sum of station, that is arithmetic sum of that particular station. What this simply means is that the error, because we are going to be working with the nothings part first, we are going to correct for the nothings part before we can now go to the listing part. But the same formula is applicable to both of them. So the error for the nothings is, if you check here, it is plus 0.049. All right. So that simply means that we are going to write 0.049 above over the total arithmetic sum for the nothings. For the nothings is, if you check here, this is the total arithmetic sum. All right, the last arithmetic sum you have on the nothings column, and the nothings arithmetic sum of the data nothings column. Okay, if you check the last arithmetic sum you have there is the total arithmetic sum, and in this case it is 996. So we are going to just write 996, then multiply by the arithmetic sum of station. That is, in this case, if we have this peg 1, we want to get the correction for the nothings, okay, to peg 1. So the arithmetic sum of nothings, okay, the arithmetic sum of nothings for peg 1 is 167. Do we get it now? So if you check, the nothings arithmetic sum is 167. So in this case, we are going to write 167. So when you punch this, all right, in your calculator, we are going to have something like this. So let's punch together. So let's introduce our fraction sign. Then we have 0.049, okay, over the total arithmetic sum is 996, and multiply by 167. So here we have, if you look closely, we have, okay, 0.008. 0.008, that is the error for this peg 1. So remember, we are adding the sign plus 0.008. Do we get it now? So the same way we are going to do for the next station. Remember, it is the error over the total arithmetic sum of the particular side we are working with. In this case, it is the nothings multiplied by the arithmetic sum of station. So in this case, the arithmetic sum of peg 2 is 238. So we'll just come here to edit. Instead of having 167, we are going to be having 238. 238. Okay. Then here we have 0.012. Please do approximate to 3 decimal values. So 0.012. Okay, so remember the sign is effective, 0.012. Sorry, we have so sorry for that. So it's supposed to be here. So 0.012, and next station is to peg 3, and we are just going to keep editing the last for the station. Okay, the station arithmetic sum here is 530. So and we are having 0.026. All right, so it's 0.026, and we are just going to write that down here plus 0.026. So that is how we'll keep editing for each station, just using this particular formula here to get for the correction for each stations. And that is all for the nothings aspect. So when you get to this stage, and get to this stage, you will find out that you are having the same exact when you edit to the last arithmetic sum. Alright, so and that is how it is for the delta, for the nothings correction. So we are going to move down to the Easton's correction. So the same formula is applicable. What is just going to be happening is that this will change and this will change, as well as all these values will change. So what we'll be having, this is for k nothings. Okay, that's for nothings, and we have for instance. For instance, now the error is 0.006. Okay, 0.006. Sorry for that. 0.006 over the total arithmetic sum for the instance. Checking the column here is 1340. All right, 1340. Then multiply by arithmetic sum of, that is the arithmetic sum of station, each station. So in this case, for the first station, it is 208, 208. So we are now going to do for station 1 arithmetic sum, right, 208. So all we have to do is to come punch that in our calculator. So punching that will be equals to, here we have 0.0009. So approximately it is plus 0.001. Okay, that is the correction to peg 1. So all we have to do is just to come and keep editing. So for the next one is 421. Okay, the arithmetic sum is 421 for 2 peg 2. Okay, that is the station 2. Alright, so we are just going to edit that to 421. Okay, so what we have now is 0.00 approximately 2. So plus 0.002, and that is how we will keep editing for each arithmetic sum, for each arithmetic sum. And that is that. So if you find out we have the correction for each successive stations, for the nothings and for the instance. So these are the corrections with their signs. Alright, so what we are going to show you quickly next is just to get the corrected coordinates. That is the last value in each box. Alright, so how to do that is just simple arithmetic something, for basic mathematics. So for this particular unknown station, we want to get the corrected coordinate for 2 peg 1. Alright, that's why we have here 2 station. Alright, so what we are going to be doing is just this uncorrected value plus this correction. We are going to have the corrected. Here, this uncorrected coordinate for the instance here plus the correction, we are going to be having the corrected. And that will be done using the red pen here. So guys, just doing that is just simple, like I said earlier. So when you do this plus this, you are going to have this. Alright, when you do this plus this, you are going to have this. And those are the corrected coordinates. So when you do this, which is the uncorrected plus the correction, you will have the corrected. Okay, the uncorrected coordinates plus the correction, you will have the corrected coordinates. And that is how it is being done for the rest of the station. So that is how we achieved this uncorrected plus the correction. Okay, you are going to get the corrected coordinates, and that is the end for the traverse computation, the forward computation sheet. Maybe in subsequent times, depending on how you people are encouraging us, so we are going to show you on how to do the back computation. So thank you for watching. We are going to see you next time.